All right, we're on 9.01 for geometry today, which is on similar polygons, and we're going to focus mainly on triangles today. But we'll start with our definition of similar figures, which really we are just saying that you have two figures that are the same shape with the same shape, but not necessarily the same size. And there's two things that must be true in order for the figures to be considered similar to each other. So those things are, number one, they must have all of their corresponding angles must be congruent. Sorry about that. So we've got corresponding angles and they have to be congruent to each other. All the corresponding angles have to. And then also all of your corresponding sides have to be in proportion to each other. So it's not just any two figures that are the same shape but different sizes that are similar. They have to meet these two really specific requirements. So we need to have all the corresponding angles must all be congruent and the sides must be in the same proportion. So I'm going to give you first a similarity statement, which, just like with triangles, is really important that you follow. So this is a quadrilateral. ABCD is similar to QRST. And I'm also going to draw those quadrilaterals for you. And obviously not drawn to scale. And this is QRST. So what this similarity statement tells us right here is that we know angle A, must be congruent to angle Q. B matches up with R, C with S, and D with T. So first of all, you should be able to identify all your congruent angles. So knowing angle A is congruent to angle Q, D to T, B to the second letter, which is R, and then C to S. Also be able to set up proportions for your sides to check to make sure they're all in the same proportion. So I'm going to give you some values here for the lengths of each side. That one's going to be 9 rad 2. This one will be 8, 12, 6, and 6 rad 2. So let's identify all of your proportional sides. All right, so for the first pair, let's take AD. So which side should AD be proportional to? Well, AD is your first and last letter, so that's the first and last letter. Here would be QT right here. So we know that AD must correspond to QT. I already wrote that. And in terms of their lengths, AD is 9 and QT is 6, which we can reduce to 3 over 2. So now we want to hope that all of our corresponding sides are going to reduce to 3 over 2, which we call a couple different names for it. Our constant of proportionality, or our similarity ratio is another name for it. But it's really just the ratio of the sides. So now let's take side DC. So DC is your last two letters, so that should correspond to the last two letters over here, so that's going to be ST. So let's check their length. So DC is 12, TS is 8. And if we reduce that, it gives us 3 over 2. So that's good because that's the same as our original proportion that we got. Let's check the rest. So let's take CB next, and CB will compare to, CB is the middle two, so SR. CB has a length of 9 rad 2, SR has a length of 6 rad 2. Reduce those, our rad 2 over rad 2, those will cancel out, and 9 over 6 reduces to 3 over 2. Good news there again. And then lastly, we have side AB, which should correspond to side QR. AB is 18, QR is 12, which again reduces to 3 over 2. So that tells us that our similarity ratio is 3 over 2, which means all of your sides reduce to 3 over 2, as long as they're corresponding sides. That also tells us, which we'll talk a little bit about later, that the ratio of your perimeters will also be 3 over 2. So any corresponding sides and your perimeters will all reduce down to a ratio of, I don't know what that extra letter is there, ratio of 3 to 2. The angles will not be in that ratio because the angles, the corresponding angles, are congruent. So they're exactly the same. So that does not fall into that 3 to 2 ratio. All right, so let's look at an example here. I'm going to go on to a new page. So given that triangle ABC is similar to triangle RST. So this is A, B, C. We know AB is 8, BC is x plus 1. And this is RST. ST is x minus 2, and RS is x minus 1. All right, so we want to solve for x here. So in order to solve for x, we know that our two triangles are similar. So we know two things. One, that their corresponding angles are congruent to each other. So angle A is congruent to angle R, B to S, and C to T, and that their sides are in proportion to each other. So typically we take whatever one comes first, and that's the one we put on top. So we can compare triangle ABC to triangle RST. So when we set up our proportion here, we want to set up the ratio of our sides. So we want to take, if we take side AB, that'll correspond to RS. So 8 over x minus 1. Whatever ratio that reduces down to, that has to equal the ratio of the other pair of sides. So let's take BC. So notice everything from triangle ABC is on the top, over, and that side will correspond to side ST, which is x minus 2. So we can set up a proportion just like we did here. Well, we didn't set up a proportion here, but we know that the ratio of all of the sides has to reduce down to the same numbers. So here, if we set one pair of sides equal to the other pair of sides, we know that those fractions will reduce down to the same numbers because they are similar triangles. So once we set up our proportion, now we can cross multiply and solve. So I have 8 times the quantity x minus 2 equals, and since these are both binomials, make sure you put both of them in parentheses. And now it's still a little tricky of a problem because we have two binomials being multiplied together. So we're going to need to FOIL those, and we need to distribute this over here. So pause the video and see if you can try to solve for x on your own. All right, so we'd have 8x minus 16, and here I'd FOIL because it's two binomials. So I have x squared plus x minus 1. So now my x's cancel out, And since I have an x squared and an x, I want to get that equal to 0. So I want to keep x squared positive, so I'm going to subtract the 8x and add the 16 over here. So I have x squared minus 8x, 16 minus 1 is 15, equals 0. Now with this trinomial, I can go ahead and factor it. Since there's a 1 in the front, I don't need to use P's and C's. You can, but you don't have to. I'm going to go straight to guess and check. So I need two numbers that multiply to 15 that add to -8, which is -5 and -3. Draw my line, set each of those equal to 0, and I get x equals 5 and x equals 3. So just double check to make sure in the original problem that you wouldn't get any negative numbers or any zeros. So 3 minus 2 is 1, 3 minus 1 is 2, 3 plus 1 is 4. So that would work. And if I put in a 5 for any of those x's, I would also get nice positive natural numbers. So these both would work. So I have two different answers, two different possible values for x. All right, let's look at another question. So this one says, the sides of a quadrilateral are 8, 10, 12, and 15. Find the length of the longest side of a larger, similar
Motion detected at the front door.
quadrilateral with a constant of proportionality. So just showing you some different terms, all for the same thing, of 2/5. So a constant of proportionality is the same thing as your similarity ratio. So what that means is it's the ratio that all of the corresponding sides should reduce down to. All right, so if we want to find the length of the longest side here, then I need to look and say, okay, well, which is the longest side of this similar quadrilateral? So I know the longest side here is 15. And I know that I want my ratio of sides to reduce down to 2/5. So I know that 2/5, I can set up a proportion, has to equal, when the ratio of the sides reduces down, it has to equal 2/5. So ask yourself first, what number is bigger, 2 or 5? Well, 5 is bigger, so 2 is smaller. So I would put the smaller quadrilateral on the top and the larger quadrilateral on the bottom. So we know that we want to find the length of the longest side of a larger quad. So I know that I do not know the longer side of the larger quad. I do know the longest side of the smaller quad is 15. So now I've set up this nice proportion. Anytime I have two fractions that equal to each other, I can cross multiply them. So go ahead, pause your video and cross multiply and solve for x. So you should have gotten 75x equals 2 or x equals 37.5. So that would be the length of the longest side of a larger, similar quadrilateral. Okay. Next, we're going to talk about the different ways that you can prove two triangles to be similar to each other. So there's 3 different ways. And these are all like your shortcut ways. So, as opposed to getting all the sides congruent and all of the corresponding sides proportional, we have 3 different ways or shortcuts to prove triangles are similar. All right, so the first way is the most common way, and that is by something we call angle-angle similarity. So angle-angle similarity. So it's important not to get these confused with the ways we prove, the 5 ways we prove triangles congruent to each other, because they are going to look a little similar. So angle-angle only works to prove triangles similar to each other. It does not work to get triangles congruent because with similarity, again, all your angles must be congruent, but your sides are just proportional to each other. So here I would have corresponding angles, 2 pairs of corresponding angles congruent. Now we want the shortest way, so that's why we don't say angle, 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 because we know that all triangles add to 180 degrees. So if I know that these 2 angles are congruent to these 2, then I know their third angles must also be congruent, because if I subtract these 2 from 180, it's going to give me the same thing as if I subtract these 2 from 180. I also want to practice here writing your similarity statement. So I'm going to give you letters. And we know that they're similar to each other. So this would be by angle, angle. Their corresponding angles need to match up. And your similarity statement, we would take your first triangle, so let's call it RST, is similar. And here's where it's really important to match up your corresponding vertices. So R needs to go with W. S needs to go with the X, which means T needs to go with the Y. So that would be your similarity statement right there. Okay, so that's the first way. Second way we're going to talk about is side angle side similarity. So don't confuse this with your side angle side congruency. Side angle side, it's saying that the 2 pairs of sides have to be proportional, not congruent. Proportional sides, not congruent to each other. So that's where it's different than if we had, if we had congruency. All right, so let's say this is B, D, E, C, and A, and this side is 24, 18, 12, and 16. So to prove it by side angle side, you'd want to show that, like here, you have your vertical angles congruent. So it has to be the included angles, just like it is with side angle side and congruency. But then we'd also have to show that your corresponding sides are proportional, meaning they both pairs of sides reduce down to the same thing. So to set them up, you want to try to match up whichever one is longer on this triangle, with whatever one's longer on this triangle. Because otherwise your proportions might not match up. If you did 12 over 24, then that reduces down. You guys can go ahead and reduce that in your head or in your calculator. Compare that to the ratio of 16 over 18. And does that give you the same thing? And the answer is no. 12 over 24 should have given you 1/2, where 16 over 18 does not give you 1/2. So here instead, we'll take 12, which is the smaller of these 2 sides, and match it up with the smaller of the 2 sides here, which is 18. And let's see, does that equal 16, the longer of the 2 sides, over 24? So now we can reduce those, and you guys can reduce them in your calculator. So you could do 12 over 18. So one way that makes it a little easier is to use the alpha y equals button and then do 12 over 18, because then it gives you back the fraction. You don't have to change it to a decimal, as opposed to doing 12 divided by 18. And then you'd have to hit math and then enter for fraction to get the 2/3. So you could do that, and then you could also check 16 over 24. And that also gives me 2/3. Or another way of doing this is to cross multiply them. So multiply 12 times 24 and 16 times 18, and they both give you 288. So we know if the two diagonals are equal when you cross multiply, that it's a true statement. So we have two pairs of proportional sides, which tells us that the two triangles are similar by side angle side. So pause the video and try writing out your similarity statement now. All right, so to do that, you should have taken, let's take triangle ABC, we'll call the first one. And so I know that this side, and if it helps you, feel free to use some colors. So AB is proportional to BE, and 16 here is proportional to 24. So when I write that out, I'll have A, B, C. So A to B is purple. So I want to start here. E to B is also purple. So that would be E, B, and then D. So that is the second way of proving the triangle similar. And the third way is by side, side, side similarity, which means you have three, just box those up as well, right here. Three sides that are proportional. So for that one, I'm gonna give you two different triangles again. So we'll call this one CAT and HOG. So now for this one, we want to show that all three sides are proportional. Again, we're not talking that the sides are congruent, because they're not going to be, because one triangle is smaller than the other. We want to show that all three are proportional. So again, to make it the easiest for yourself, take the smallest of the three sides first. So that's 12, and the smallest side over here is 9. So let's do 12 over 9. That reduces to 4 over 3. Then let's take the middle side. So that would be 20 and 15. So let's do 20 over 15. And that gives me 4 over 3. And then let's take the longest sides, 24 and 18, reduce that, which gives me 4 over 3. So all of the three pairs of corresponding sides are all proportional. They all reduce down to the same constant of proportionality, or the same similarity ratio. So go ahead and pause your video and write the similarity statement for this one. So I call this CAT. Again, if it helps, take colors, make the longest side, so the 24 went with the 18, and the 12 right here is the smallest side, went with the 9. So if I went from C to A, that means, so I went towards the blank side here. So I'm going to go towards the blank side. So that would be O to G to H. So CAT is purple blank next. So we want to go purple blank next. All right, and that's it for the different ways of proving the two triangles to be similar to each other. So we don't, like with the congruency, we had 5 different ways: side, 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 angle, side, angle, side, angle, 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 side, and right triangle, HL. With similar triangles, you only have 3 ways, and this right here, angle, angle similarity, is going to be the one that you really see the most. That's the one that comes up most often for our triangles. All right, so now let's do a couple more practice. And for these, I want you to figure out if the triangles are similar to each other before we do our setup. So in triangle CGD, AE, segment AE is parallel to segment CD. If CA equals 8, AG equals 4, and ED equals 9. So I want you to tell why, state why the triangles are similar. And then I want you to find the length of GE. That's A, E, G, C, D. So we've got a triangle inside of another triangle here. So we also kind of want to figure out, well, what two triangles are we talking about? So we need to find those two. So we have this small triangle on the top, AGE, and then you have this large triangle, CGD, as well. Now we know that these two are parallel. And that's really all we're given besides some lengths here, which I'll go ahead and label. CA is 8, AG is 4, and ED is 9. So I need to figure out what the two triangles are that are similar and why they're similar. So if I have parallel lines, that means I can find a transversal, and I've got two parallel lines cut by a transversal. If you need to extend them, you can. And now you can see these corresponding angles pop out, hopefully. I also have corresponding angles on this side if I look at this transversal cutting through the two parallel lines. Plus, this little triangle and the big triangle share this angle right here. So I can actually get all three angles in the small triangle congruent to all three angles in the large triangle. But I only need two angles in order to get the triangles similar to each other. So I know right off the bat here that I can use angle-angle similarity. Let's also practice writing out your similarity statement. So pause the video here and write out your similarity statement. All right, so you've got triangle AGE. So A has this one mark, so I know that's going to match up with C. And then I went to G next, which is my reflexive angle, so that has to match up for both of them. And then E would match up with D. So that's my similarity statement, and I know that they're similar by angle-angle similarity. So now let's worry about finding GE. So let's call GE X. Now that I know the triangles are similar, I know that their sides are proportional. So be very, very careful here though. So side AG should correspond to side CG based on our similarity statement. So that's AG and CG. A lot of students try to match up 4 to 8. And while actually, if you did do that in this problem, it does work because the lines are parallel to each other, which is something we're going to talk about in another lesson, it would not work if you had been given these two sides. So I'd like you to be in the habit of really paying attention to what you're given. And if we're doing it by using similar triangles, then let's match up those similar sides. So we're going to take 4, which is the length in the smaller triangle, compared to 8 plus 4, which is 12 in your larger triangle. So the 4 corresponds to the side that's 12. Remember, in similar triangles, all of our sides have to be in the same proportion if they're corresponding sides. So that means X in this triangle must correspond to this whole side. So GE has to correspond to GD. So GE is right here, corresponds to GD. Now this is X and 9. So just like here we did 4 plus 8, we would do X plus 9. So X in the smaller triangle will correspond to X plus 9 in the larger triangle. Now we have our proportion set up, so we can go ahead and cross multiply. Go ahead and pause your video and solve for X. All right, you should have distributed here and then subtracted your 4x over to get 8x, and then your final answer would be x equals 4.5. All right, so again, being able to set up your proportion is really, really important here. So the next one says in triangle ACD, CD equals x, BC equals 90, AB equals 80, and EB equals 110. Find x. And again, I want you to state the similarity statement and why the triangles would be similar to each other. So first we'll start with a picture though. This is a right triangle. This is BE, A, D, C. And BC, it says, is 90, AB is 80, the length of BE is 110. Find the value of x. All right, so first let's start by finding our similar triangles. So again, I only see two triangles here. I see this top little one and then the big triangle. So I already have one pair of congruent angles, and then these two triangles also share angle A by reflexive property. It's in both of those triangles. So we know the triangles are similar by angle-angle similarity. We also know that two lines perpendicular to the same line are parallel to each other. So that also tells us that these two are parallel. So if you had wanted to get all three angles, you could have gotten these because they're corresponding angles as well. All right, so let's talk about our similarity statement. So pause the video here and write down your similarity statement. All right, so I'm going to start with triangle ABE. So I started with the small one. I went from the reflexive angle to the right angle. So in the big triangle, I'm going to start with A, which was the reflexive angle, go to the right angle, which is C, and then to D. Again, if you had something like BAE, then here you would have CAD. So just make sure that those match up appropriately. All right, now is a good time to pause your video and to set up your proportion here. So again, your corresponding sides need to be in proportion. So just like we did on the last one, find the corresponding sides and set up your proportion. All right, so for this one, we know that side BE should correspond to side CD. So that's 110 over x. So now I need to set it equal to a pair of sides that I know both the lengths of, because I already have a variable in here. So I know the length of AB is the other side, the only other side I know in this little triangle. And AB will correspond to then AC. So AB is 80, and then AC, you would have to add those together to get 170, and then you would put 80 over 170. And then you would cross multiply, and you can leave it as a fraction or a decimal. So that leaves you with either 935 over 4 or 233.75. All right. Next thing that we'll talk about, the last thing today, is just those ratios again. So if you have the ratio of your sides, that is going to equal the ratio of your perimeters. So they're the same. Whatever the ratio of the sides is, the ratio of the perimeters will reduce to that same number. If you have the ratio of the sides, though, and you're comparing it to the ratio of the areas, you would need to square that ratio of the sides. So the ratio of the areas is equal to the ratio of the sides squared. And if you're talking about a solid, then the ratio of the volumes, now remember volume is cubic units, area is square units, you're going to cube the ratio of the sides. Or in this case, you could also cube the ratio of perimeters, or square the ratio of perimeters would also be the same. So let's do a couple practice of these. So the first one says the sides of a triangle are 6, 8, and 10. Find the longest side of a similar triangle with a perimeter of 18. See if you can set this one up on your own. All right, so hopefully you looked for the longest side. Here is 10. We know that the perimeter of the other triangle is 18. I can find the perimeter of this triangle by adding 6 plus 8 plus 10 together, and then I can compare those ratios. So we get 24. So now we know that the ratio of the perimeters of the other triangle is 18, of our given triangle is 24. So again, we know the ratio of the sides is equal to the ratio of the perimeters. So the ratio of the sides must reduce to the same ratio that the perimeters reduce to. So now I'm going to take the longest side, which is 10. Now 10 came from the triangle that has a perimeter of 24, so it needs to go down here across from my 24. Would not work if I put it in the top. And then I'm looking for the longest side of the triangle with a perimeter of 18, so that one has to go across from the 18. And now go ahead, cross multiply and solve. All right, so you should have gotten 7.5 for that one. That would be the longest side of the other triangle. All right, and the next one says given segment PL is parallel to segment MG, AL equals X, LG equals 4X. If the area of triangle MAG is 300 units squared, find the area of triangle PAL in square units. I'm also going to give you a picture here. Okay, so for this one, let's start by labeling. So AL is X, LG is 4X, and I know the area of this big triangle is 300 units squared. So let's take a look here at our two sides that we know are X and 4X. Now, I want to find my two different triangles. I know these two are parallel, so I know that I've got corresponding angles. I have that reflexive angle at the top. So I know my two triangles are similar by angle-angle similarity. And that's going to be triangle PAL. And sometimes it just helps to have this written when you're matching up your sides. So PAL would be similar to triangle MAG. So here I have AL, that would need to correspond to this whole side. So that's X plus 4X, so that's 5X. So if I take X over 5X, I can reduce that down because these X's would cancel, leaving me with 1 over 5. So now I know that the ratio of my sides has to be 1 over 5. Well, I want to find the area of the other triangle. I know the area of triangle MAG. So if I know the ratio of my sides is 1/5, that means if I square it, that'll give me the ratio of my areas. So 1 squared is 1, 5 squared is 25. So now that's my ratio of areas. So I'm going to take that ratio of my areas and set it equal to the ratio of my areas. So triangle MAG, that is my larger triangle. PAL is the smaller triangle. So 1 is smaller than 25. So I want to put PAL at the top and MAG in the denominator. So I don't know the area of PAL. Now I've already used X in this problem, so really important that you do not use X again. So I'm going to call that A, and then the 300 will go here. And now you're just going to cross multiply. So 300 times 1 and 25A. So 25A equals 300. So A is going to equal, if I divide both sides by 25, that would be 12 units squared, which is the area of triangle PAL. Okay, so definitely a trickier one for that one. And then the last problem that we'll do, really quick one, is number 7, which says if the sides of 2 rectangular prisms are in the ratio of 2 to 3, find the ratio of their volumes. Okay, so if we know their ratio is 2 to 3, this time instead of squaring them like we did for the area, you're going to want to cube them. So we're going to cube each one, which will give us 2 cubed is 8 and 3 cubed is 27. So our ratio would be 8 to 27 for the ratio of their volumes. So just like we did with the areas, you want to square it if it's area, cube the ratio if it is volume. All right, and that is it for today. Sorry, I had to pause this video a record number of times. Too many things going on, I guess. But if you have any questions at all, I know some of this can be a little bit tricky, but please let me know and I would be happy to help. I hope you have a great day. Pie out.